Welcome everyone to our Winter 2023 series of OTF Connects webinars entitled Animating the Revised Math, Science, and Technology and Science Curriculum. My name is Peter Beans and I'm honored to be your moderator for today's session with Marc Husband and Tina Rapke entitled Mental Math in the New Curriculum, What, How, and Why. Before we begin, I'd like to do a land acknowledgement. We acknowledge first and foremost that we are gathered in the province of Ontario on the traditional territories of various Indigenous peoples who have been present on this land known as Turtle Island since time immemorial. More specifically, the location of this event is Mississauga, which is in the Dish with One Spoon territory. It is the traditional territory of the Wendat, Mississaugas of the Credit First Nation, Haudenosaunee, Wyandot, and Métis peoples. We acknowledge that this has been a meeting ground for generations. We are grateful to the stewards and caretakers of this land. As advocates, teachers, and educators, we understand our collective responsibility to honor, protect, and sustain this land. We further recognize and honor within the membership of OTF and our participants at this event, those who are Indigenous to this land. This practice of recognizing the ancestral and traditional lands in which we work, live, and play is a concrete action that we undertake as a first step towards reconciliation between Canadians and the Indigenous peoples of this land. But it is not our only step. Collectively and individually, we must seek to denounce the injustices and wrongs that have been committed against the First Nations, Métis, and Inuit peoples, and to dedicate ourselves to cultivating and maintaining relationships based on mutual respect and truth. Okay, I'd like to introduce our presenters today. Dr. Tina Rapke focuses on all grade levels of mathematics teaching and learning, including the education of future teachers. She loves being in the classroom working with teachers and students. She has 20 plus years of teaching experience and is currently an associate professor at York University. Marc Husband earned his PhD in 2019 from York University. He is currently an assistant professor in the Faculty of Ed at St. Francis Xavier University in Antigonish, Nova Scotia. Did I get that right?
Yep.
Okay. His research is situated in the field of mathematics education with a focus on teacher education. He is interested in the kinds of professional learning experiences that influence teaching practices in mathematics classrooms. Current and recent projects include elementary teachers' conceptions of mental mathematics, the potential for using number talks to promote equity, eliciting and documenting students' mental math ideas, and investigating ways to make math visible and visual. And with that, I will turn it over to Dr. Tina and Dr. Marc.
All right. I'm going to share our screen. Is that good, Tina? Can you see it?
Yep,
I can see it. Yep.
All right.
Looks great. And
Looks
so these
good.
are the things we're going to answer today, right? Like, why is it in the curriculum? How can we teach it, right? We're going to be going over these things and we're going to talk about how we can teach it so that kids are happy and confident and people are having really a great time in the classroom and learning, right?
That's right, Tina. And you know what? We had an introduction. Peter gave us a great introduction. So I don't know how much more we want to say, but should we just continue on?
I think we can. Yeah, let's just go.
All right. So here's what we're going to do today. We're going to debunk any sort of there's some myths out there about mental math, and number talks, Tina.
Yeah. So Marc and I have been working, I don't even want to know how many years now, Marc. I feel old every time I start to think of this. But when was our first project in mental math? It was before it appeared in the curriculum.
Yeah, 2014.
Was it 2014? Okay, wow. So it's been a while that we've been really looking at mental math and spending tons and tons of time in classrooms with teachers and kids working on mental math. So we've heard all kinds of things. We've worked with lots and lots of teachers, and they've told us, like, you know, what they think is hard about teaching mental math before we start working with them, and all the things that they believe. So we're going to try to debunk some of that first, and then we're just going to go in and show you exactly, you know, what we can do with mental math and the things that have been successful with lots of teachers and lots of kids.
And we're going to provide some really concrete ideas today on how to support your students, right? At this. So really concrete strategies and ways to support your students.
Yeah, perfect.
Okay. Tina, why did mental math end up in the curriculum?
So we were excited when this happened. And I believe one of the reasons that it ended up in the curriculum is because there's tons and tons of research that says how mental math can actually build a foundation for kids to be successful in all kinds of areas in math. So that's really this is really why it ended up in the curriculum. Now, this is the trick though, Mark, with anything else, it's always in the details. So we're not talking about, because when we started looking and once it appeared in the curriculum, you and I were like super excited and we're like, great, this is fantastic. But then when we started talking to some of the teachers that we work with and how they were actually using in their classrooms, we were like, uh-oh, there might be a little bit of mismatch here, because the way that, it's appearing in your classroom mental math, I don't know if it's actually going to be the best way to build this foundation for kids.
Exactly. So there are some nuances to this that we really want to pick up and talk about. Yeah.
But they're nuances that anyone can learn. So that's why we're here today, because they're things that anyone can do and anyone can learn. And we can be really supportive. And we've got tons of resources and support so that, people can turn around tomorrow and start teaching mental math in a way that's foundational for kids.
Absolutely. And I think, one of the things when we talk about mental math, a lot of teachers are familiar with number talks, right? So mental math and number talks sort of go hand in hand. And so to bring people into conversations about mental math, we often, the way to bridge them is through the number talk. And these are, lots of teachers are familiar with them, doing them in their class about 10 minutes, right? And we had a research project where we went into a classroom once a week for the whole school year with grade 2 students. And it was, and that's where that second bullet comes in, right, Tina? That consistency, right?
Yeah, so it seems really easy. Well, I don't even want to say it seems easy. Scheduling wise, it seems easy to fit in 10 minutes to do a mental math talk. But then once you start to see, well, it has to be consistent. So you have to do that like 2 or 3 times a week. You have to block off 10 minutes of these sort of, a lot of teachers have been calling them mini lessons. Like they talk about mental math talk or number talks as mini math lessons. And so that's what we need, is just like these short pieces, but they need to be like consistent over time.
That's right. Yeah.
And Mark, maybe we should ask people, because some, like, even though we see a lot of number talks, there's still lots of people who haven't heard of number talks, right? Because it is fairly new, right? Like I would say,
that's true.
I would say more than half of the teachers that we've talked to say like don't know what number talks are and haven't heard of them yet. So but basically it's a number talk is just, you ask them a mental math question, you give kids time to think about it, and then you take up solutions.
That's right. And there's like an oral component, but also a very visual component, right? So we're going to be chatting about both of those. Yeah, we went in, and one of the things I wanted to bring up, Tina, was that when we went into the grade 2 classroom, we actually timed ourselves, right? We actually took a phone and we timed ourselves because we wanted to like see what we could do in 10 minutes,
Yeah, and it turns out for grade 2, 10 minutes is too long.
Yeah. We actually brought it down to 7, remember?
Yeah. So for all of those people who know anyone, because I know this is grade 4 to 8, but for all grade levels, past like grade 4, like I would say 4 to 8, 10 minutes is your max. Try to keep it to 10 minutes. And like we would actually be really honest with the kids, and we would put our timer on our phone, and that's all we would do. We would do 10 minutes. As soon as the alarm went off, we were out of there, right? And I think that helped them know that it's just a short little period of time. It's a time to engage, time to talk about how you see things in your mind, and then that's it, right? Then you're done.
Yeah, exactly. Okay. All right. So let's get down to these myth busters, Tina, right? We're going to do some myth busting first. So number 1, mental math is boring.
So that's what we heard a lot about, right?
Yeah, yeah, yeah.
When it came out in the new curriculum, and we were talking to teachers and we were talking to students, and we are like, Mark and I are like, we're so excited for mental math. And that's what's so great about today, is that I think that everyone joined this because they too are excited about mental math. But we're kind of a small group of us that are excited about mental math, because most people, when we said we're excited about mental math, they were like, that is so boring. Mental math is
Hey.
so boring.
Well, and not only that, Tina, like they might have these memories, and we've talked about these memories of mental math from like decades ago, where it was like, okay, it measured only my speed and accuracy, right? So it was like mad minutes, right? So we sometimes it's associated, the idea of a mental math is associated with mad minutes from years ago. Remember that?
Yeah, so a lot of people talked, once we brought up mental math, they talked about how they did mad minutes, or how they
Yeah.
are doing mad minutes. They talked about memorizing. Yes, like there is sort of a nightmarish thing that comes out, where I'm just looking in the chat
Yeah,
box,
Nicole.
Mark, and
Yeah.
yeah, Nicole's talking about a nightmare. Yeah, like most people are cringing, right? When you say
Yeah.
mental math, and there's Mark and I going, like, we're so excited, and they're like, what is wrong with you?
Yeah, 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 yeah. And
So
and like Nicole and like it's funny because from my just surveys of working with teacher candidates in teacher education classes, you have about half the people have like terrible math anxiety from mad minutes, and the other
yeah.
half some people who are lovers of it, right? So I understand that some people do love these things, and whereas like Tina, one of the things that we've noticed about number talks when we focus on mental math is that there's actually more opportunities for everyone to love this.
Yeah, that's the thing, right? Like,
Mhm.
and probably in the next myth is busting this about, because after people said it was boring,
Mm.
um, then, and it's about mad minutes memorization, and we're like, what?
Yeah.
And they're like, well, what are you talking about, right? Because clearly we were talking about something different when we said mental math than what other people were, that were like cringing and sort of, pushing us
Right.
away, like physically putting their hands up to us, right?
Yeah.
So let's show them what we think of mental math, what it is
Yeah.
to us.
Yeah, so we've got this up here right now, and the first thing that I like, one of the very first things that we need to say is that when we went into the grade 2 class, and we spent that year focused on mental math, we were fascinated by the ideas that students had, and we focused on them.
Yeah, and that's why it's not boring, because it's always, like, Mark, I'm always surprised by what kids tell me and how they are telling me that they see it in their minds. Like, it's always it's surprising and challenging to listen to exactly how they're like describing what they're seeing in their minds,
Yeah,
right?
yeah,
So this is the debunk. It's not boring, because it's not boring to kids because it's about their ideas, right? And it's
yeah.
not boring to others because it's about us trying to figure out like what they're trying to tell us that they're seeing in their minds, right? These images that they're seeing.
Yeah, and then the number talk becomes the opportunity to actually use some materials to get kids to see things. And one of the things that happened to us, Tina, which I still talk about, I think it's one of the most fascinating things that has happened to me in a classroom, was when the kids had the 10 frame, and the counters were in the 10 frames. So it was a 10 frame full of counters, and the kids were going like this to count the counters, and Tina and I were both like, okay, we're doing something different. And that's where we went to read research on these subitized images, right, Tina?
Yeah, so originally when we went in and we asked kids what they were seeing in their minds, Mark and I, everyone's heard about 10 frames. So we brought some 10 frames out, and we thought that's what they were seeing in their minds, right? So that's what we offered them. And the kids were like, heck no, right? They might have said in those words, but they were like, no, that's not what I'm seeing in my mind. And they came up and they just like started moving things, and it wasn't fitting the 10 frames at all. So that's when we actually had to go to the research from psychology to see how children see numbers in their mind. And so a lot of people have seen this before. It was all about subitizing. So then we started actually arranging things in so it's easy for them to subitize. And that's when we really hit the jackpot. So Mark, the real difference between, mental math and thinking about it with mad minutes and memorization is this small tweak. And it's not small, it's actually quite large, but shifting to think about mental math about and really focusing on the way that kids see things in their mind. So that's the big secret, the big key to teaching mental math in ways that it'll help kids build foundation and they'll be happy, confident learners. So that's the big key to it.
So let's ask the group, Tina, like about this and, this 9+5, and we see how, we might ask kids like, oh, where's the 9? And they'll say the 5 and the 4, and where's the 5? And they see that. But then, the next question we asked Tina was about, usually around like, what is 9+5? And they say 14, but like, what did they move?
Yeah, and how did they get that, and what were they seeing in their minds?
Yeah.
And so there's like, so it came up to like, what are you seeing in your minds? And we would have kids actually talk to their partners before they told us, and then we would actually have to move these dots, and we would have to show and be like, is this how you're seeing the dots in your mind? How do you see them? What's moving? Which one's moving? That kind of thing. So let's ask the audience. So we've got 9 up here in red, and we've got 5 up in blue. And so we really want to know what 9+5 is. And we all agree it's 14. And even with kids, we go, yeah, okay, great. Everyone's got 14. Now we actually have to talk about how we're seeing it in our minds. So let's just ask the group, how do you see these dots moving in your mind so that you get 14?
Yeah. So we've got an idea. Nicole says, I see the 10 frame with 9 on the left and then 5 on the right 10 frame. Okay, so she does see the 9 and the 5. And so then 2 groups of 5 add 4. So Monica's saying 2 groups of 5 add 4. So I want to know, like, those 2 groups of 5, are they the ones that are already there, or did you move? And see, we have somebody say add the 5 and 5 and then 4. So there doesn't sound to be any moving for those people. Oh, but we have Allison. Allison's saying move 1 from the 5 to make a group of 10. And so Allison's idea is to, and Kim says the same. She says move. Now Kim is actually more specific. I love this. Move the middle yellow dot from the 5 over to make it a 10 on the other side. So it's a 10 and 4.
Yeah.
You hear that, Tina?
Exactly. Yeah. Well, and so there's all kinds of ideas here. And this is what we really need to capitalize on with students, is actually moving these as they're saying it. So someone said, move that 5, the 5 on the right. So the yellow 5, move that right next to the red 4. And then you have the 4, or right in between sort of things. So you have those 10s.
Yeah.
So, and even it's hard to talk about when you're not actually moving the mark. And that's what our point is too, is that we're trying to, take up your ideas here, but it's hard when we're not actually physically able to move these dots either.
Yeah. Mm-hmm. And what's interesting is I think there seems to be consensus that it's the middle dot, right? But what's interesting with kids, Tina, remember the year we were there and we would move like one of the dots and they'd say to us, no, that's not the one I moved, right?
Yeah. And you get to know, the beautiful thing about this too, Mark, is you get to have a lot of fun with kids and you get to know them so well too, right? And obviously they start to actually own and honor their own ideas, because they're like, no, not that one. Take the middle one and put that one in the middle, right? And you're like, oh, okay, yeah, sure, I'll do that. No problem.
Yeah. And they get quite provoked to go, here, I'll show you. No,
Yeah.
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 Okay, should we go to the next one?
Yeah, let's do it.
Okay, debunk. Next one. Everyone likes talking about their own ideas, especially kids, Tina.
Yeah, so you've heard us talk about, like, I think everyone can tell how excited we are to talk about some of the times that we have listened to kids tell us their ideas, and they're like, not that one, take this one, right?
Yeah.
So
yeah.
they get really, really excited. Who doesn't like talking about their own ideas? I like talking about my own ideas. If we're all honest, we all like our own stuff, right?
Totally. Yeah. And to build on that, it's funny because when I notice when we first start connecting ideas, this kids will start to go, well, I like that because it's like my idea, right? So we do like to see our ideas in other people's too.
Yeah, and that's part of the thing too. So when we first approached a bunch of teachers about doing this in their classrooms, the first thing that we heard was like, it's boring, and it's just mad minutes of memorization. And then once people sort of bought into this, okay, no, it's about images and how kids are seeing them things in their mind, then it got to like, well, that's really hard because kids aren't going to tell me first,
Yeah.
right?
Mhm.
And what if they just have no ideas? So that's when Mark and I turned around and we started making a lot of videos with kids.
Yeah,
Um,
yeah,
and so, in the classroom, what we would say is like, oh, we heard from, if it was the very beginning, oh, we were just actually in another grade 2 classroom, because often we were in lots of classrooms.
yeah.
And we say, in that grade 2 classroom, someone showed me this, right? And we would show them to start them off. And as soon as you get them started to talk about it, and even better, if they see another student talk about it, they get more comfortable to share their own ideas too,
Mhm.
when they find some of their own ideas in others. So we've
So
made
do
it
you-
like really easy for everyone. So if you're having some of these things, we're going to show you some videos that we have today that are free on Vimeo, and you can use them tomorrow in your classroom if you want,
Yeah.
around how you can use these videos and what the videos do. So that's just easy. They're like open and go lessons.
Yeah. So do we want to move to video? We're going to continue on a little bit more, right?
Yeah, we can continue. We don't have too many slides.
Yeah, yeah. So I thought so. Okay. So number 3, to teach it well, it's going to take a lot of planning and time. So this is a really important one to debunk, Tina, because there's this idea. First, the idea is, mental math is this really awful experience of anxiety ridden, and it's just me and quickly going check mark, check mark, check mark, X, 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 right? And it's really time consuming, and everybody knows teachers have no time, right?
Yeah, no one has any time, right? Luckily, Mark, you and we get to sit around and we get to think about what kids tell us and how they think all day long, right? We have
Yeah.
a little bit of a breather that way. But again, lots of teachers that we work with, they're like, I've just got no time. And I'm like, I totally understand. So
Yeah.
we were
Yeah.
very, very conscious of that. And that's another reason why we started making these videos, so that, when we weren't in the classroom with teachers, they could just hit play. They could just hit play and let it go.
Mhm. Yeah. Okay. So we have open and go lessons ready for you from grades 1 to 8, right? And just like you're saying, Tina, and we're going to focus on 4 to 8 today.
Yeah, because we've got grade 4 to 8 teachers. So I'm excited to show them some multiplication, some percents. If we have time, we're going to look at some division involving fractions.
Yeah. Yeah. So we're going to start with the 5 times 6 one.
Yeah, and that's in grade 4 for those of you
Yeah.
who want to know where it is in the curriculum. So we're going to do 5 times 6. And this video, we have it's 9 minutes, and we included a whole bunch of different ways that you could do it. Specifically, when you're doing it in your classroom, you can just watch the video right from the beginning to the end. But what we're going to do is we're going to just pretend like we are we're in a classroom right now. And so we're just going to ask you as students, we're going to ask you to put sort of your student hat on and pretend that you're a student. And we just want you to think about 5 times 6. And how you would actually compute it. Now, right away, a student's going to go, it's 30. And it's like, yep, great, it's 30. But I'm really interested in how you're actually figuring that out in your mind, right? Because maybe you just actually know this off by heart and 30 comes up. But in grade 4, they probably haven't practiced that much, that, their multiplication tables are just coming up.
And you can see kids, this happens with kids all the time. You go 5 times 6 and they go like this. 30.
Yeah.
So they've done something.
They've done something. Yeah. If they don't say 30 right away, they've thought something in their minds, right? It's not like
Right.
30 is just flashed right in their brains and that's the answer.
Right.
And so, Mark, we already have some people who are giving us strategies as
Yeah.
students of how they're doing 30. So these are interesting ones. So counting by 5s, right? We go like 5, 10, 15, because they're thinking of 6 groups of 5.
Yeah.
We've got that one.
And we've got 5 times 2 times 3.
Yeah.
Yeah, that's interesting. So taking that 6 and pulling it apart, right?
Yeah, and so we actually have an awesome video. It's in like the strategy in here that shows some of that.
Yeah.
And I can't wait to show people now.
Oh, yeah, look at this. We've got some really, Bruce is saying 10 times 3, and Allison is saying known facts 5 times 5 plus another group of
Plus
5.
another 5.
Yeah.
Yeah. So this is interesting. So Mark, we really need to, this is one of the strategies we have to show them today for sure in this video, because this video has about 5 different strategies. And in your classroom, you don't have to use all these, but we have this amazing video for 10 times 3. And it was done really, really thoughtfully. And it was based on like tons of kids that we had worked with. And they gave us very, very specific instructions of what we were supposed to put in this video and how we were supposed to do it. Do you remember, Mark?
I do.
They were very, very specific. They were almost, it was like, yes, I'll do it. Don't worry. Yeah, I've got it. Yeah, I understand, guys. So we've got this. So in a classroom, we just ask them to think about 5 times 6. We don't take up any answers. We say, yes, the answer is 30. And then we just ask them to watch the video. But we ask kids to watch the video in very specific ways. So even if you're in a classroom and you're going to be doing it on your own, if you want to do it on your own, if you feel that confident right now, you can try that out. But you ask the other kids to just listen, but listen in a very specific way, or watch in a very specific way that you see if they use the same idea as you. So if they've used the same strategy as you.
Yeah. So I'm like, and so our audience, Tina, like we've got Tanya who's saying some interesting things, and as well as some other, Kara and Nicole. And so now we want to really draw their attention to, the stuff that they're thinking about in the video, right?
Yeah, exactly. And so someone actually has their 8-year-old with them. And so if you can ask them to watch this video, that would be amazing. Just again, we're going to watch this video. And so everyone sort of has an idea of how they did this now. And so your challenge is to watch this video and see if they've used the same strategy. And if they haven't, then you have to pick the strategy that's closest to yours.
Closest to, that's a good cue. Yeah.
Closest.
Okay.
So there might not be your strategy exactly, but you need to figure out which one is closest to yours. So let's go ahead and just play the video for everyone now.
Okay.
Hello, amazing math learners. Today we're doing 5 times 6, and Louis is going to tell us how he solved this.
Yeah.
So what is this, Louis?
This is 5 times 6.
Okay, but how do we make sense of it? Like, what are you seeing in your mind?
I see 5 groups of 6.
Oh, so you read it as like 5 groups of 6. So
yeah,
let's bring that out, okay? So we have 1 group of 6.
2 groups of 6. 3 groups of 6.
Okay.
4 groups of 6.
And we just need 1 more, right? Okay.
5 groups of 6.
Now, to figure out 5 times 6, we have to figure out how many in total are here, right?
Yeah.
Okay. How are you going to figure that out? How are you going to count it?
Can we split the 6 into 5 and 1?
Absolutely. So let's just see what that looks like. So you're going to take each 6 and you're going to split it into 5
and 1.
And 1. So basically, here's 1 group of 6, but you're really going to just like put a line right there so that it's 5 and 1, right? And you're going to do that for all of them.
Mm-hmm.
So how about if I just do that and draw a line so that all of the 6s are now 5 and 1. Okay, so what are you going to do now?
We're going to do 5 times 5.
Oh, so 5, so you're going to go 5 times 5, which is this, right?
Yeah.
Because you have 5 groups of 5, so 5 times 5. And then you're going to, you're going to add this group?
Yeah.
So 5 times 5, which is there, and then 5 times 1.
Yeah.
Now, 5 times 1 is really easy, right?
Yeah.
It's just equal to what?
5.
Perfect. And what's 5 times 5?
25.
How do you know that so quick?
Well, I just do 5, 10, 15, 20, 25.
Yeah, let's just show them. So when we do, we just keep track of the 5s on our fingers. So we go 5, so that's, then this one would give us 10, 15, 20, 25. So 5 times 6 equals 25 plus 5. And I bet you know that really quickly.
Yeah.
What is it?
It is 30.
Awesome. You are fabulous, Louie.
Thank you. Bye.
Hi, math learners. Today we're doing 5 times 6, and I'm going to share an idea that Jerome shared with me. So first of all, he said he reads this as 5 groups of 6. So let me show you where they are here. So here's one group of 6, and 2 groups of 6, 3, 4, 5. Okay, but you know what he told me was that he actually wants to not read it this way as 5 groups of 6, but this way as 6 groups of 5. And I went,
That's really
oh yeah, that's way
significant,
easier
Mark.
because, you know, skip counting by 5s.
Did you want me to pause, Tina?
Yeah, because that's really significant, right? Because
Yeah.
kids, when they first approach this, they just read as 5 groups of 6, and then they realize that, hey, you know, they can actually, if they like 5s better, they can think of it as 6 groups of 5. So
Yeah.
that's really like when they start to figure out like why 5 times 6 is equal to 6 times 5. And so let's just watch the video and see how they explain that.
Is easy. And I said, but where's the 5s? And then he said, look, I'll show you them in here. And he said, look, 1, 2, 3, 4, 5. So he said, there's one group of 5. And then he said, if we just move these over a little bit, we can circle all the groups of 5 and we can see 6 of them. So I'm not taking any away, I'm just moving them, because to figure out 5 times 6, we have to figure out the total amount. Okay, so here's the other group of 5. That's 3 groups of 5, 4 groups of 5, 5 groups of 5, and 6 groups of 5. So basically, instead of seeing groups this way, to make 6 groups of 5, he sees them this way. And then he went, look, 5 for this one, 10 for that one, 15, so there's 15 altogether here, 20, 25, and then he said, and one more group to figure out the whole thing, so 6 of them, would be 30. So 5 times 6 equals 30. What a great idea.
So Mark, just because I want to make sure that we get to another question with everyone too, and I'm excited to show the 3 times 10. Can we just skip? I think it's the very last strategy, because this is, I can't wait for everyone to see this, because students were so particular on what we needed to do. Actually, you just passed through it, Mark. Did you see it?
Yeah, it's the next
one. It's
one.
not the last one. It's the next one. Perfect.
Yep. Okay.
Hi everyone. Today Anna's going to show us how she did this question.
So what I did is, I don't like this question. I know a way easier one. I'm going to double this and half this.
Oh, okay. I think I see it. So you're going to go double the 5, right? Mm-hmm. So times it by 2 to get 10. And then you're going to have this 6, so divide it by 2 to get 3. So you're actually looking at 10 times 3.
Yeah, which is really easy.
Well, let's show people what this looks like so they know that it's going to work every time, okay? So I have here, I have 1, 2, 3, 4, 5, 6. So I have 6 in each row, and I have 5 rows, right? 1, 2, 3, 4, 5. Okay, so basically to figure out 5 times 6, you have to figure out how many squares are here altogether, right? Mm-hmm. But you said, I don't like this question. I'm actually going to change it. So you're going to half the 6, right? So,
yeah, so we'll split it right here.
So I'm going to just grab a pair of scissors, and I'm going to half the 6. So let's see what that looks like. Thank you for the help. Okay. Okay, so you half the 6, so like 3, 1, 2, 3, 1, 2, 3.
I can hold this one for you.
And then you doubled. So it looks like this, right?
Mm-hmm.
And this is 3, 1, 2, 3 times 10. And again, you didn't take any squares away. It's still the same amount, right?
Yeah, it's just a different form.
Yeah, and so what's 3 times 10 then?
3 times 10 is 30.
It's 30. So 3 times 10 is 30, which means that 5 times 6 is equal to 30.
Yeah.
That's a great job and great thinking on that.
We're gonna pause it here, Tina.
Yeah, I don't think we have to, everyone can watch the other solution on their own, because I
Yeah.
do want to do a percents question. But the big thing with this was when we were doing this with kids, they were very, very particular that we actually had to cut that piece of paper in the video.
Yeah.
It wasn't enough. Like we brought the 2 pieces of paper and we're like, okay, so we're just gonna go like half and then we're gonna move it, right? And they were like, no, you need to actually grab a pair of scissors and you need to actually cut it so people can see it as a whole first, with like 1 piece of paper, and then you cutting with the scissors to show the halving and doubling so that it actually.
That's right.
So that was like, do you remember how particular they were, Mark, about that?
I know. And then we did it with bigger numbers. I remember doing it with 26 times 5, and they wanted to cut.
Yeah.
Make it 10 times 13 and cut there. And it's interesting because in the chat, like that actually this idea came up. So Bruce, I'm hoping Bruce just saw his idea or saw their idea in that
Yeah,
DM.
and you know what? And it's so amazing that like, kids have these little tricks, right?
Yeah.
But to actually see it visually, how it actually works every time and make it like visual so that everyone can talk about it, because then all the kids in the classroom can talk about, how this actually works, how it's like taking the scissors and cutting it, right? And just moving it along. So I think that's what the big thing about mental math and visualization is.
Absolutely. And one of the things I wrote down, Tina, when I was watching that video again, and I just want to highlight the fact that when you counted and you pointed and you moved the objects and you really took your time, because we wanted to make the mental image, the moving of it visible for people to see. And that was really important.
Yeah, and it's for people to see and then discuss, right? That's the big part, is mental math is about discussing how people are seeing in their minds. Mark, we got to go on to, why don't we do the percent one, and we'll leave people watch the division and fraction ones on their own, because I know that there was a lot of interest in percents.
Okay, so this is the 20%, right? So 20% of 60, and in the chat pod, maybe you want to quickly think, how would you figure out 20% of 60? We'll just give you 30 seconds.
And Mark, this just shows how fast you can do this in your classroom, right? We've got 5 minutes left and we're going to do it in 5 minutes. So everyone just think about 20% of 60, and then we're just going to play the video. Yeah.
And so I see some ideas. We're not even going to talk about them. We're just going to ask them to see if they can see their idea in the video, right, Tina?
Yep.
Okay, ready?
And Jerome has a really good idea that I'm going to share with you today. So he told me to actually write down 20%. And what he said is this actually means 100 cents. And so he said 20 per 100. So here I have 100 things, and I'm going to show you what 20 per 100 looks like. So I'm just going to replace 20 of them. So there's 10, and then another 10. And so that's what 20 per 100 looks like. So there's 10 in each row, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 10 rows. Okay, so he said that's 20% of 100, but he really needs 20% of 60. So he said, that's fine. I'll just actually look at 60 of them. So here's 10. Then 20. 30, 40, 50, and 60. So this is 60, And if you look at the 20%, it's 1, 2, 3, 4, 5, 6, and there's 2 rows, so it's 12 is right here. So he said, look, 20% of 60 is 12. What great ideas. Hi everyone. I was working with this amazing student named Latoya and figuring out 20% of 60. Now what she told me was that 20% makes her think about 1/5 or dividing by 5. She said she thinks of that because 20, 40, 60, 80, 100. Okay, so what she wants to do is she wants to divide 60 by 5. So I've got 60 things here. So 1, 2, 3, 4, 5, 6. And so there's 6 in each row, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what she said is, she said, I'm going to make 5 equal groups. So let me show you what that looks like. So here is 1 equal group, and she's making 5 of them. So 2 equal groups, 3 equal groups, and I'll just circle them for you. There's 1, here's a second one, here's a third one, here's a fourth one. And she said, so 20% is one of these, how much is in one of these equal groups. So let me just change the color on one of them because I'll count how many are in here. Okay, so here it is right here. And then she told me, look, Tina, 20% is actually dividing by 5. So if 60 divided by 5, she said, look, I know that 50 divided by 5 is 10, right? So, and then what she has to do is she just has to do 10 divided by 5. So that's going to be 2. So there should be 12 here. So let's make sure. So we have 1, 2, 3, 4, 5, 6, and then we've got 2 of them. So 20% of 60 is 12. What great ideas.
Tina,
We finished just in time.
we got 1 minute.
5:44.
Yeah, I
5:44.
know.
We've got 1 minute to spare. So I think the only thing I want to say about that is if you notice the images, they're actually quite similar, right? And the cool thing about these two is that we've shared the idea of per song. So it's per 100. That's what percent really is. So it's kind of cool how all these different ideas come out in these videos and that the visuals are very, very particular to the question.
The only other thing I want to say too, Tina, is that Andrea and Deb and Diane and did something that was slightly different, right? And so what we've been finding in classrooms is that we have to, we want to provoke them to notice their idea in others, right? And so that question that you asked earlier is like, which idea is it closest to? So we would ask those people that I just mentioned, well, which idea is your idea closest to, right, Tina?
Yeah, exactly. And then that provokes some discussion too. And then,
Yeah.
Research tells us that the best way for kids to learn is to compare and contrast their ideas.
Yeah. Yeah. Comparing and analyzing. That's right. Okay. Well, Tina, it's 6:45 here and 5:45 there.
We had a question earlier about the manipulative that you were using to move all the dots.
Oh, yeah.
Yeah. So this has been a long, again, I can't believe it's since 2014, Mark. Originally, we started off with our manipulatives. They were actually rockets, the little candies. But the colors weren't deep enough. The kids couldn't see the colors as much. So they asked us to actually use something with more color. So then it moved. We started using not rockets. What are the other ones? Sweet tarts, because the color's a little bit darker. And we were putting like that little tacky stuff on the back of them and putting them on whiteboards that way. And you can imagine some of the younger kids were like, they wanted to eat them, but we were like, no, they're so gross, you're going to get really sick. And we'd be like, we were in another class and who knows if they were picking their nose or what was going on. And then we actually moved to the magnets that you saw on there. Now those magnets are actually on what is called a light board. So there's a whole bunch of lights that actually make them neon and stuff. And then there's just like a little mover of like, we have different movers. Some of them are 5, some of them are 10. And we just basically, when we go to classrooms, we have a little bag. I don't have it near me right now, but we have a bag and it's just a bunch of those little magnets and then the movers. And then we just throw things up on the board and move them. So we've sort of streamline that process. Thank you for that question.
Yeah. I saw there was another question about the like people are wanting to know about division and people are wanting to know about grade 5, 6 stuff. And so there is that, Tina, all of these things exist, right? So do you want to just direct them?
Yeah, so we've got a whole bunch of videos on our Vimeo. So Mark, can you actually just go onto the Vimeo and just show them what's available there?
Yeah.
We have some of these videos there. If you just, I think if you just click on Math Healers, it should show all of our videos and they can just go through and, oh, maybe not. Maybe if you click on the icon.
If you could drop the
When
link
we've got
in the
the-
chat as well, that way I'll have it for the notes for everybody.
Yeah.
Yeah, maybe just click right on there, Mark, and it should come up. All of our videos should come up.
Yeah. Yeah.
And there's lots of fun stuff in there. So there's videos just about number talks. If you notice, this is what we were talking about before, our math happy hour. And last summer, Mark and I did a series around for parents around how they could give allowance during the summer to keep up kids' math skills. And that was quite fun to have. And I think all of those are on Vimeo as well.
Yeah, I don't know why it's not.
You can see some of them here, Mark. There's like 17 minus 9, 20% of 60. We saw that one. If you click further down, there's like some multiplication ones. There's like a whole bunch of different ones on there that people can just pick and choose.
Yeah, but they're really organized. Oh, here they are. They're really organized.
Yeah, if you click on maybe the video, just right there, because it's about, if you click on videos, it should be more organized. Yeah.
65
So we've
videos.
got 3 divided by a half. That's a really fun one if people are interested, because kids, like it's so, some of the experiences that kids have with fractions are just not great. So definitely check out that one. Here's all the stuff that was about our summer happy hour around using allowance. We've got 44 times 8. That's a good one as well. We've got a bunch of division ones if you see. Some percent ones. There's a whole bunch of different ones in there that you can just scroll through and check out.
Yeah.
And then if they're looking for more, we have a website with like hundreds and hundreds and hundreds of videos. And it's just inspirational math teaching. And you can check us out there too. Mark and I are trying to get onto YouTube. So those of you who are YouTube fans, that's our next big thing as soon as we figure out how to get on YouTube.
There, I just dropped the link into your channel.
Oh, great. Okay, thanks. Oh,
Yeah.
Mark's just opening it now. We don't have anything in French, unfortunately. That's our next big thing is to do. But you'll see there's like hundreds and hundreds and hundreds of videos.
Who was asking? Somebody was asking about grade 4 or division. So like if you go into grade 4, you can see, you know, lots of grade 4 stuff here, multiplication, and then lots of videos here, right? And then on Vimeo, yeah.
There's a bunch of them too, yeah. Is the question and answer period being recorded, Peter? I just want to make sure that, okay.
Still being recorded, yes.
Okay, because we are going to have a period where it's not recorded for those people who want to ask questions that don't want to be recorded.
Yeah, if you want, I can go ahead and do the closing and then we can stop recording and then open.
Yeah, sure.
Questions. Yeah. Okay. All right, I'll go ahead and share again.
Okay, yeah. Should I stop sharing?
Sure.
Yeah.
Okay, have I accidentally closed Zoom? No, I'm there.
Yep.
Okay. Yeah, except I'm not getting my share bar for some reason.
Yeah. Oh,
Mark, someone's asked us if we're going to be doing workshops for the other grades too.
yeah. It says, will you do a workshop for grades 1 to 3?
Yes, we would love to. Maybe Peter can get us an invite.
Talk to OTF. Yeah, they might be doing Connects sessions in the summertime again. I'm not sure.
Yeah.
Okay,
Yeah.
great. So hopefully, yeah, email OTF and ask them to bring us back for the younger grades. We'd love to come back. Hey, Mark.
I do. I know. That'd be great.
Let me just find the chat window. I'm going to drop some links in the chat. So there's Mark and Tina's email addresses. I've dropped a link in for the feedback form. So if you don't get a chance to take care of that now, it'll also be included in the email that you'll get either tomorrow or Monday, depending on how quickly OTF can turn this around. I've also dropped down a link for the OTF Connects calendar, although this is the last session of the winter 2023 series, but I'm hoping there's going to be sessions in the summertime again. And there's a link to the OTF YouTube channel, which is where you'll find this session as well as others. So Mark and Tina, I want to thank you. This brought back a lot of nightmares from math class. And math, like I said last night, math has changed so much, but it's nice to see that it's broken down into the most basic elements, and then, you know, it all comes back to you, of course. But anyway, thank you so much.